Okay, for each sequence, state whether the sequence is increasing, decreasing, or periodic. If the sequence is periodic, write down its order. Okay, so A, part 1. So to get the next term, you're doing the previous term plus 3. So U1 is equal to 7. U2 is equal to U1 plus 3, which is equal to 7 plus 3, which is equal to 10. U3 is equal to U2 plus 3, which is equal to 10 plus 3, which is equal to 13. U4 will be equal to U3 plus 3, which is equal to 13 plus 3, which is equal to 16. So you have the sequence 7, 10, 13, 16, so on. This, you can clearly see this sequence is increasing. Okay, so we don't have to do part 2 because it's not periodic. We don't need to do part 2. Okay, B. So to get the next term, you're taking the previous term and you're squaring it. So part 1 is U1 is equal to half. U2 will be equal to, oops, let's write it out again. So U2 will be equal to U1 all squared, which is equal to half squared, which is equal to a quarter. U3 is equal to U2 all squared, which is equal to a quarter all squared, which is 1 over 16. And U4 will be equal to U3 all squared, which is equal to 1 over 16 all squared, which is 1 over 256. So our sequence is a half, a quarter, 1 over 16, 1 over 256. You can see it's getting smaller and smaller and closer to 0. So this sequence is decreasing. So because it's decreasing, it's not periodic, so we don't have to do part 2. Okay, let's do C now. Okay, C is not a recurrence relation. It's just the nth term notation. So C, part 1 is U1 will be equal to sine of 90 times 1 degrees. So sine of 90 degrees is 1. U2 will be equal to sine of 90 times 2 degrees, which is equal to sine of 180, which is equal to 0. U3 will be sine of 90 times 3 degrees, which is equal to sine of 270 degrees, which is equal to negative 1. U4 will be sine of 90 times 4 degrees, which is sine of 360 degrees, which is equal to 0. U5 will be equal to sine of 90 times 5 degrees, which is sine of 450 degrees, which is 1. So we're back to 1. That means the sequence will be 1, 0, minus 1, 0, 1. Because we come back to 1, it's going to repeat itself. So 0, minus 1, 0, so on. So this sequence, because there's repetition, so this sequence is periodic. So then you can see this part repeats itself. 1, 0, minus 1, 0. 1, 0, minus 1, 0. So part 2. If the sequence is periodic, write down its order. How many numbers are there in each period? There's 4. So it's the order is 4. Or you can say periodic sequence of order 4. Okay, next question. The sequence with the recurrence relation UK plus 1, which is the next term, is equal to P times the previous term plus Q, where U1 is equal to 5, where P is a constant and Q is equal to 13, is periodic with order 2. find the value of P. So that means, let's rewrite it because we know what Q is. So U sub K plus 1 is equal to P times UK plus 13. So we do know that. And we also know it's got order 2. So it's got order 2, and U1 is equal to, no, U1 is equal to 5. So U1 is equal to 5. To find U2, you're doing P times U1 plus 13, which is equal to P times 5 plus 13, which is equal to 5P plus 13. U3 will be equal to P times U2 plus 13, which is equal to P times 5P plus 13 plus 13, which means 5P squared plus 13P plus 13. Since the sequence is periodic with order 2, this implies U1 must be equal to U3, which implies 5P squared plus 13P plus 13 must be equal to 5. If we rearrange it, we get 5P squared plus 13P. 13 take away 5 is 8. If I factorize it, I've got 5P here, P there, plus 1 here, and plus 8 there, because then I get positive 8 as my constant. 8P plus 5P is 13P, which implies P is equal to negative 8 over 5, or P is equal to negative 1. And P is a constant. So it should have been find the values of P. Next question. A sequence has nth term an is equal to cos 90 n degrees, where n is greater than or equal to 1. Find the order of the sequence. So a1 will be equal to cos of 90 times 1 degrees, which is equal to cos of 90 degrees, which is just 0. A2 will be equal to cos of 90 times 2 degrees, which is equal to cos of 180 degrees, which is equal to negative 1. A3 will be equal to cos of 90 times 3 degrees, which is equal to cos of 270 degrees, which is 0. A4 is equal to cos of 90 times 4 degrees, which is equal to cos of 360 degrees, which is equal to 1. A5 is equal to cos of 90 times 5 degrees, which is equal to cos of 450 degrees, which is equal to 0. And A6 will be equal to cos of 90 times 6 degrees, which is equal to cos of 540 degrees, which is equal to negative 1. And you can see the repetition happening. So that means my sequence is 0, minus 1, 0, 1, 0, minus 1, 0, 1, so on. So you can see these 4 repeat itself. So periodic sequence of order 4, because the 4 numbers are repeating themselves. B is sum of r equals 1 to 144 of AR is equal to A1 plus A2 plus blah blah blah, all the way up to A144. Now, some of these numbers are the same, remember. A1 is the same thing as A5, is the same thing as A9, and so on. So it'll be the same thing as, if I do 144 divide by 4, because there's 4 numbers, I end up getting, I made a mistake here, it should have been 444 here, yeah? So that's where my numbers are going wrong. So it'll be 444 divided by 4 is 111. That means it's the same thing as getting 111 lots of A1 plus 111 lots of A2 plus 111 lots of A3 plus 111 lots of A4. Because remember, this sequence is periodic. So it's the same thing as 111 times 0 plus 111 times minus 1 plus 111 times 0 plus 111 times positive 1. Now, if you look at this, it just gives you 0 minus 111 plus 0 plus 111, which is equal to 0. The final answer will be 0. Next question. A sequence of numbers A1, A2, A3 is defined by A sub n plus 1, which is next term, is k minus 3k over the previous term. The sequence is periodic of order 3, where k is any constant. Given that A2 is equal to 2, show that k squared plus k minus 12 is equal to 0. So if A2 is equal to 2, then A3 will be equal to k minus 3k over A2, which is equal to k minus 3k over 2. A4 would be equal to k minus 3k over A3, which is equal to k minus 3k over k minus 3k over 2. Now I need to simplify this, so I get k minus 3k. If I write the first term over the same denominator, I end up getting 2k minus 3k over 2, which gives me 3k over minus k over 2, which is the same thing as 3k times 2 over minus k. Oh, I forgot something in the middle. So let's go back. I thought the first term k. So these mistakes happen in an exam. Be very careful. So I get k minus 3k over minus k over 2, which is the same thing as k minus 3k times minus 2 over k, which is equal to, the k's cancel out, k plus 6. So that would be A4. Okay, A5 will be k minus 3k over A4, which means k minus 3k over k plus 6. Now what we do know is, since the sequence is periodic of order 3, it implies A2 must be equal to A5, because it obviously moved on by 3 positions. So that means 2 must be equal to k minus 3k over k plus 6. Okay, so we need to obviously simplify this. If I multiply through by k plus 6, I get 2 times k plus 6 is equal to k times k plus 6 minus 3k, which means I end up getting 2k plus 12 is equal to k squared plus 6k minus 3k. I have to go here, which means I get, if I take everything to the right hand side, I get k squared plus 6k minus 2k minus 3k minus 12 equals 0, which means I get k squared plus k minus 12 equals 0. Okay, so that's what I wanted. So B, I'll have to go over here. Oops. Okay, so for part B, given that A1 is not equal to A2, so B, find the value of sum of 1 to 1 to 1 of AR. So first thing I need to do is find K. So if I've got k squared plus k minus 12 equals 0, if I factorize it, I get k plus 4 times k minus 3 equals 0, which implies k equals negative 4 or k equals 3. Okay, if k equals negative 4, then I've got an plus 1 is equal to -4 minus 3 times minus 4 over an. And remember, we don't know what a1 is, so let's leave as a1. a2 is 2. So if we substitute 2 into this formula, I get minus 3 times minus 4 is 12. 12 divided by 2 is 6. Minus 4 plus 6 is 2. So we're getting a2 is equal to a3 in this instance. So a2 is equal to a3 when k is equal to -4. Therefore, k cannot be equal to -4 because we've got this condition. Sorry, a1 is equal to a. So we're getting 2 everywhere. If you substitute in, if you keep substituting 2 in, you're going to get, and in that means a1 must be equal to a2. a1 is equal to a2, which is equal to a3, which is equal to a4, so on. So k cannot be equal to -4. So that means k must be equal to 3. Therefore k is equal to 3, which means we get an plus 1 is equal to 3 minus 3k over, minus 3 times 3 is 9. So 3 times 3 is 9, so minus 9 over an. Which means, therefore, we've got a1. a2 is run by was 2. So if I do 9 over 2 is 4.5. 3 minus 4.5 is minus 1.5. That would be my second term. 9 divided by minus 1.5 is minus 6. 3 minus minus 6 is 9. So the next term will be 9. And then it repeats itself. So 2 minus 1.5, 9. And a1 would now be the one previous to 2, which is 9. Okay. So that is my sequence. Okay. So I need to do sum of r equals 1 to 1 to 1 of AR will be, because I've got 1 to 1, 1 to 1 divided by 3 terms that are repeating themselves, I get 40 and 1/3, which means I'm going to get 41 lots of A1 plus 40 lots of A2 plus 40 lots of A3. Because I'm going to get one extra term, which is obviously going to be the first term. So it'll be 41 times 9 plus 40 times minus 40 times 2, no, that's the second term, 40 times 2 plus 40 times negative 1.5. And if I put that into my calculator, I end up getting 389 as my answer. And it looks a bit messy. The only thing I would do here is I'd write A1 here, and then I'd write therefore A1 is equal to 9 because of the fact that it's repeating every 3. Okay, next question. A sequence of numbers U1, U2, U3, U4 is defined by, this is the next term, 1 over 1 minus the previous term, where U1 is equal to 2. So U1 is equal to 2. Determine the value of sum n equals 1 to 20 of UN. Then U2 will be equal to 1 over 1 minus U1, which is 1 over 1 minus 2, which is equal to minus 1. U3 is equal to 1 over 1 minus U2, which is equal to 1 over 1 minus minus 1, which is equal to 1 over 2. U4 is equal to 1 over 1 minus U3, which is equal to 1 over 1 minus a half, which is equal to 1 over a half, which is equal to 2. So we're back to 2, which means it's going to be in a loop. So that means we've got the sequence 2 minus 1 half, 2 minus 1 a half, periodic sequence of order. You can see it's repeating itself every 3 numbers of order 3. So that means if I want to work out sum of n equals 1 to 20 of UN, if I do 20 divide by 3, it's 6 2/3, which means I'm going to get 7 lots of U1, because I'm going to get the first term 1 extra time and the second term 1 extra time. So see, 7 times U1 plus 7 times U2 plus 6 times U3, which is 7 times 2 plus 7 times -1 plus 6 times a half. 14 take away 7 plus 3, which is equal to 10. A sequence is defined by the recurrence relation next term 1 over the previous term, where A1 is equal to P. So A1 is equal to P. Show that the sequence is periodic and states its order. So A2 is equal to 1 over A1, which is equal to 1 over P. A3 is equal to 1 over A2, which is equal to 1 over P, which is equal to P. A1 is equal to A3, therefore periodic sequence. So that we've got P 1 over P, P 1 over P, P 1 over P. So that means we've got every 2 it repeats itself, so of order 2. B, sum of R equals 1 to 1000 of AN in terms of P will be 500 lots of A1 plus 500 lots of A2, because we've got 1000, half of them will be A1, half of them will be A2, which is equal to 500 times P plus 500 times 1 over P, which is equal to 500 times P plus 1 over P. Find the sum of the first 98 terms of the sequence defined below. So UN plus 1 is next term, 3 times the previous term, and then the previous to the previous term. So this one's a bit more complicated because you're taking previous to previous term. So be very careful with that. So you've got U1 is equal to 2, U2 is equal to 5. So U3 will be equal to 3 times U2 plus 9 over U1, which is equal to 3 times 5 plus 9 over 2, which is 15 plus 9, 24, divided by 2, which is 12. U4 will be equal to 3 times U3 plus 9 over U2, which is equal to 3 times 12 plus 9 over 5. So 3 times 4 is 36, plus 9 is 45, 45 divided by 5 is 9. Okay, U5 will be equal to 3 times U4 plus 9 over U3, which is equal to 3 times 9 plus 9 over 12, which is equal to 36 over 12, which is 3. U6 is equal to 3 times U5 plus 9 over U4, which is equal to 3 times 3 plus 9 over 9, which equals to 9 plus 9 is 18. 18 divided by 9 is 2. Last one, hopefully, because if we've got 2 already, if we get 5 in the next one, then we know it's a periodic sequence. U7 will be 3 times U6 plus 9 over U5, which is equal to 3 times 2 plus 9 over 3. 6 plus 9 is 15. 15 divided by 3 is 5. So we've got 2, 5 again. So we've got the sequence 2, 5, 12, 9, 3, 2, 5, 12, 9, 3, 2, 5, so on. So this sequence is periodic of order, periodic sequence of order 5. That means if I'm trying to work out sum of n equals 1 to 98 of UN, and it's the same thing as 98. And 98 divided by 5 is equal to 19 3/5. So that means I'm going to get 3 extra U1, U2, and U3. So 20 times U1 plus 20 times U2 plus 20 times U3 plus 19 times U4 plus 19 times U5, which is 20 times 2 plus 20 times 5 plus 20 times 12 plus 19 times 9 plus 19 times 3. Put this into our calculator, we get 608.